Hey everyone, how are you going today? Obviously this is a bit of a different video. We're a little bit darker, we're a little bit intimate, and it's because we're going to be looking at this PCBWay badge that I made for one of their design contests. It's not going to be a long video, but it's not going to be about our SBC content. I've got some more of that here and some more of that here that will be coming out in the following weeks, but that's not for now. Now we're going to make a short video about this badge and why I made it and what it means. So if you want to see a bit of Arduino or STM8 and some RGB LEDs and design decisions and how I won, I think, about 300 bucks in credit, hang around. If not, what I'd recommend you do is hit the like button anyway to support me, hit subscribe if you haven't before, and then skip to the end of the video and watch like 10 seconds from there before closing it, just to help the algorithm. It'd be much appreciated. But if you are interested, I'm going to show you how I made this and some of the problems that I had and why AI sucks. So thanks for coming by. If you're leaving now, if you're not, let's get into it. So firstly, finding out about this was actually through Maker's Muse. Here's another Aussie, and I don't know if you've seen him, but he makes some really great content about tiny robots, about 3D printing, about CAD. It is quite excellent. So I don't like newsletters, I don't like social media, and so I didn't actually find out about it. And I was watching one of his videos, I think it might have been this one, and he mentioned this, here we go, this design contest that PCBWay do each year. So this is for the 11th year, and I thought, oh, that sounds interesting. Now it was a fair bit into it, like this started March the 3rd, and I found out mid-April. So I was on borrowed time, but the idea was that it's their 11th birthday, so 11 years of innovation and beyond with PCBWay. Must include PCBWay, the number 11, there's their logo, explain what it means to you, email it in, and yeah, look, it was a bit of a challenge, but I thought I'd give it a good crack, and in the end, it turned out pretty good, in my opinion. I designed this with a few things in mind, and as you can see, those cogs are a bit like my logo, which is hidden under the battery there. I did design this with a few things in mind though, so when I submitted it to PCBWay for the assessment, I thought I'd actually do a bit of a write-up, and I have to thank my missus for this too, because she gave me a fair bit more insight than I actually expected to have. So you can see here that there is the Chinese pine and the bamboo. That was her idea. So I had this snake idea. I had the light bulb idea here, which, you know, innovation light bulb moment. And so the 11 is the filament holder inside the light bulb. I should probably get one to compare, but you know, the two little metal prongs in a light bulb. And then you can see here, there's those two little, I don't know, traces, whatever. And then we've got the filament of the light, which are these little RGB LEDs. They're essentially WS2812 Bs, but made by Light, and they're 2020 format, so 2mm by 2mm, and soldering them on was quite challenging. So the snake is because 2025 is the year of the snake in Chinese culture, but it's also year of the wood snake, which doesn't come around too often. So I thought I'd use this gold Enig finish for the PCBWay logo and for the snake, which also makes it conductive and how I can do this. But then, you know, the badge is obviously a badge shape with the lanyard is showing off some rather amazing PCB milling here. And then I used the UV silk screen because it's year of the wood snake. So this added the wood element to it. And I decided I'd write all of that up. You can actually see that over here. If we jump back, I've got it all on GitHub. And I've done a bit of a full breakdown of everything here. So it's touch activated, different animation modes. It simulates the cog. Year of the wood snake. There is the UV print art. It's designed for really low power. I wanted it to be lower power, but I'll get into why that didn't work. Cycles through different modes. I've got it set to 10 seconds, but it does do a few of them, and you can click on the video to see that. It encourages human connection, so you can imagine that if you're wearing this and it's hanging from your chest and someone asks, what does it do? You can ask them to put their thumb on it. Bam, animations. And you can, of course, customize it to do what you want. And then open source, of course. So I designed it in KiCad. It's kind of Arduino. It compiles in Arduino, and I tried to share as much as I can. But I built around STM8, and I forget why I did this, because I actually made it really hard. I swear I'd seen another STM8 competition somewhere, and I thought, sure, this can probably do it. I looked up the specs, it's got enough GPIOs. Then I got these LEDs, LiPo battery, and the touch sensor, which is just the golden snake pads. If we go up and we have a look at the PDF that I submitted here? Nope, not that one. It gives you a bit of an idea of what I was aiming for. So I did put a lot of thought into this, and my partner, she put a lot of thought into it as well. That's not the current design. I did change it a little bit from that for a few reasons. But the light bulb shape for innovation, the top tab for the lanyard attachment, the complex shape to show what PCBWay can do, the number 11 as light bulb filament holders, the silkscreen process as part of their manufacturing, the PCBWay branding, putting it at the top so you know they're up in the clouds, the cultural elements, so using the snake as the E27 light bulb thread. Now that actually took some time. Jesus, did that take some time. Nice gold finish, Chinese pine and bamboo for the wood element, UV printing, and then my logo being the light bulb filament, so the cog and the gear pattern, logo on the back as well, and it symbolizes kind of our ongoing relationship, because of course PCBWay do sponsor this. Link below, $5 off your first order, and there's going to be a whole pile of coupons, a bucket load of coupons I'll get to in a tick. So I kept it under 100 by 100 mil, so you can actually essentially get it for free using the $5 coupon below, not assembled of course, but for their prototype pricing. STM8, so it's nice. STM8, so it's nice and cheap. And I'd never programmed STM8 before. I've done a lot of AT Tiny, but not STM8. That was cool. Touch sensor, voltage regulator. I didn't actually. I removed that in the end. WS2812 and yeah, I went over a bit of it there, but you get the idea. So what we ended up with initially was this. This is my first prototype that I ordered just to see if I could get it working. So I had the STM8 MCU, the LiPo connector, the 8-pin debug header. I then had an N-channel MOSFET and a Touch IC controller. Now, that Touch IC controller is the same as these touch sensors, which I failed to open, which I sell in my e-commerce shop. So I will put a link to these below if you wanted to have a play with them, but they're a capacitive touch sensor and they can be really, really handy. So you can see if I bring this a bit closer, wherever the focal point is there, you can see that IC that I was going to use. But the problem I've got here is that the touch trace actually runs all the way down the board to here, to where the pads are, which you can't see too well in this design, but they are there. They'll just print it over. Now, that distance caused some issues, of course, because if this is dealing with capacitance and that's got a lot of stray interference, it can be quite challenging to tune. So it took some conjiggering. I had to mess around with this for a while to try to get it to go. I tried shorting the touch. I actually had gotten that connector backwards. Like, it fundamentally worked, just not well. And that was very frustrating. So I ended up just shorting it to make it work so that I could debug and test it, because of course the deadline was approaching and I wanted to knock this out. But I decided to scrap that Touch IC in the end, because you know what, if these are capacitive, then one of the GPIOs on the STM8 can just read some voltage. So dump some voltage into a pad, dump the pad back to the GPIO and read the voltage. Stick a resistor in front so you're not going to electrocute your thumb in case your battery can put out a lot of current. But I thought that was a much easier way to do that. So then we end up with this second design, and it's not often my second design works, but this one did. You can see I've rearranged it a little bit, but essentially it's simplified. And I added some more capacitors, some decoupling capacitors there for the LEDs, just in case someone wanted to have all of them on. And of course, it's got that beautiful silk screen. So I was really happy with how the second revision turned out. And of course, when I assembled it, it just worked. And I'll just turn these lights off for a tick so you can actually see, oh, that's dark, what it looks like, because I really, really like this cog animation. So it starts with just the rainbow one, and then I go on through a few different colors, and this is at a quarter brightness. So these things can get bloody bright. So there, of course, is Chinese prosperous red for good luck and good fortune. I did decide to throw in a little Aussie pattern there. It looks a bit orange on the light to me, but that's a nice green and gold for Australia. And then, of course, I just went back to plain white at the end of that. And you can customize this as much as you want, any pattern, any brightness, because that is just a string of WS2812s, which are a dime a dozen, and I also sell in the shop, although not those size. Now, when I first started programming this, I actually had some significant issues. I thought I'd just be able to use STM8 Arduino, as it's called. If we go have a look over here, it's like STM8 Arduino. I was like, all right, I'll do Eno. I'll make this open source. That's the one you want. I'll make this open source. I'll use this STM8 Arduino, and you know, the standard libraries will work. It'll be great, but it did not. I mean, a lot of the problem is it wasn't even that one that I used in the end. It was a fork of this one that that was patched up, I think. Geez, I cannot even recall. But the problem was that it doesn't support C++, which Arduino does, and a lot of the libraries use. It only supports C. So I ran into a few problems and had to start looking into what libraries I wanted to use that were very C. So I ended up finding this one, Tiny WS2812 from CTXZ. And this was very, very promising. He is basically focused on the STM8S build. It does support Arduino framework in there as well, so you've got a few options, but it does talk about the issues with and without C. And all in all, it's pretty straightforward. So I thought, all right, I'll throw in some recording here of me trying to vibe code it. I'll vibe code it. I hate vibe coding. I think it's a stupid idea because I've programmed for the last nearly 20 years. But I thought, you know, C's been around for ages, WS2812s have been around for ages, and STM8s have been around for ages. So any AI can do this, but it can't. And a lot of the problem is the timing. If we have a look at the 2812 data sheet, the timing is actually very specific, and I managed to get it very, very close by guessing the amount of NOPs that I would need and how to make it work, but I couldn't get it working reliably by vibe coding it. And of course, that's how vibe coding works. You usually get 80% of the way there. In the end, I had to hand code it, and I'd vibe coded for a week and was pulling my hair out, getting angry at it just not working. When I stopped trying to vibe code it, referenced the examples that this guy included, and just wrote it myself, it was easier and it worked pretty much straight away. So long story short, got all your defines. These are the ones that really define how the cog works. You got a bit of tuning here. That seemed to work best, but if you're in a very dry environment, you want them, or you've got dry skin, you might want that lower. Those are the different modes. There's probably a better way to do that, but you can change how long each one takes and how they all work. And then they're pretty much set. That's based on the assembly. At first, we want to do the standard init process for 16 megahertz clock because we need that for how fast the data needs to be. We're going to enable the analog to digital controller, the ADC, because we need to read that analog signal. We created a little read value function. Now this is based on some stuff I found on the internet, but I had to change it to suit what I wanted. But basically just read it, wait until it gets a value, and that's then wrapped in this check touch sensor where we have our multiplication factor based on the battery voltage. Now this one is a bit of a shot in the dark because on this, essentially everything's powered straight from this battery. There's no voltage regulation because these LEDs will work down to about 3.5 volts, and this STM8 will do 3.3 to 5.5 volts. So a LiPo is going to be 4.2 down to say 3.7, which means everything's going to work within the range of the LiPo. It's just going to get slightly duller. But it does mean that some of the intended functionality might vary a little bit. We've got this multiplier that we're using based on the 10-bit ADC and what the voltage is usually going to be. But if you're running this on old batteries, maybe change that to 3700. So yeah, read the value. Once you've got it, multiply it by the factor, and if that's over the touch threshold, happy days. We then have our basic write the data to the string of LEDs, a quick way to clear them. We've got a way to set the color, and this one took a while to really figure out what to do. Yeah, it was definitely an interesting one, but in the end, it worked. So we've got our rainbow mode, and it just worked out easiest to do most of these using some sort of modulus to get that cog animation. We've got our PCBWay green, that is the right color there, but it doesn't quite look the same. Our fortune, our Australia, and then just chucking some white at it. So when this starts up, set the clock, disable all the crap we don't need, in at the ADC, set up our WS2812. Again, thank you to CTXZ for his library. Clear them and write some data. We're going to have the default right there, which is nothing. Then, of course, loop through checking the sensor. If it's not, clear it and wait a tick. And we also, this is really important, we want it to reset from the start each time. So we have to set this. Otherwise, when you put your thumb back down, it will kick off where it left. So if you want to resume, just take this stuff out. Then when it is touched, clear it. For every LED, now it's also worth noting that we've said 32 LEDs. That's just for the sake of the wrapping because of how we're using modulus. Actually, specifically, it's that bit. So if you set it to 28, it's going to behave slightly differently, but that's just how my code goes. That's to make it easier to change, if anything, and to make the math a little bit simpler. So light up every tooth size plus tooth gap LED starting at the current position. Calculate the starting position for this tooth based on which tooth you're at, and then light up the tooth amount of LEDs, which is 4 in this case, and then wrap around if needed, which is go back to the start when you've hit the end of the LEDs so that you don't get any strays, I was calling them. And set the color, do the LED thing, as I said. So set the color based on what you want each of those to be. Once you have written all of that data, once you've written all of those indexes, then write all of that to the string, update the position, update your timings, delay before you loop back. And this I don't really know about, but there was this full assert for STM8 or for the STM library that we left there just in case of a crash situation. And yeah, look, it's not complex. Once I actually did it myself, it worked really, really well. So then these, of course, finally arrived, and not that one, this one. I got the stencil for it. It did turn out to be a little bit hard to assemble, and that's because where these decoupling capacitors are kind of line up with where the LEDs are. So what I found is I did the LEDs first, and I'll cut some footage in here of that soldering process if I recorded any, and then I kind of sat my mini wear soldering iron there and did the rest of the things on the back, and I had to heat gun it a bit, so you can see there is some slight discoloration there just from the heat gun, but it works fine. And I ended up with this working badge, which I'm quite happy with, and submitted along with that PDF, put it up on their shared projects, put it on GitHub, and eventually won. Check this out. I didn't win first place, but they released this page here, which is their 11th anniversary, and they showed off the winners and everything like that. So you can see, if we jump back down here into the GitHub repo, there is actually a link to the shared projects page, and that's where I've uploaded it here. So you can just order this for yourself if you want. Shows what I used to do it, and similar sort of explanation there with the code compiled, the raw Arduino code, linked to the GitHub repo, the schematic, as open source as it can get. Then they released this. I got the email and said, you won something. And I jumped in and had a look. So for 21 days, there is still this awesome little thing going on. This is where you get heaps of really sweet coupons. I'm for sure going to be using them. So you can read this. I'm not going to read it to you. Pause it if you want to keep reading, or you're a slow reader, but it's a little bit of a history about what they do and why they're doing this. You then get to go down. Here, you get a bucket load of coupons, and this is for PCB and their CNC and 3D printing. They can print and CNC nearly any material, and it's amazing. So you normally get like a get coupons. These automatically go to your account, and you can use them straight away, and it's quite amazing. And here you can see the PCBWay team. There's a few familiar faces there from account managers and support people that we work with, but they've got an awesomely huge team. You can see some more of their details here. So using the link below, you get $5 off your first order, which means you just pay shipping if you want to use this that promo. 50% off a lot of 3D printing and CNC machining, like 6061 aluminium from $25 is pretty amazing. Now, unfortunately, my badge didn't get included here, and I was a little bit heartbroken about that because I wasn't told that there was a deadline for getting images or the design stuff in. I've submitted everything by all of the deadlines they gave, but apparently this page had already been made. So I didn't get included here. But apparently I did win. I don't know. Oh, what's this? So share your project. Yeah, I did that. Unlock 6 special cars to light up the number of 11. Ends on July 18th. Each PCBWayer who had shopping experience has 2 chances. All right, join the draw. Congrats. I won an ESP32. Cool, cool. What else? Join the draw. I won another one. All right, that's it. So you can win some free stuff in there. I've actually got that. I've got that. I've got that. They do have some cool stuff over in their store. Okay. Here is their winner blog. So this first place prize was actually really good. Filippo Castellan, sorry if I got that right. It's using the 11 for two different scales, temperature and humidity, and the way it cuts out, it turns into its own stand. So this is very definitely deserved as the winner. It works excellently. Second prize is a little bit simpler, but looks awesome. It's quite a similar sort of design. Now, this was actually a couple of people that worked on it. So you can see Guy did the original design on Instagram, and then they had 3 different versions made. And Rain is another Aussie as well, but I love Curious Scientist design, so you can always go check those out. Second prize, there's 2 second prizes. So the other second prize was to this awesome layout by Nasib. Sorry if I get that wrong, but again, I love the cogs because it's similar to me, but this looked really nice. I quite like how that was done. And the most functional one goes to Nick Electronics. So touch sensor, when the 11 is touched, the IC lights up the edge, and you can read all that. And then of course I got the most creative award. I wish they would have used a better picture, but it does explain how it works. I wish it would actually link. And so we all won some stuff, and it was good fun, all in all. I don't know if I'll put the time into doing another one because it really, really did suck up a lot of my time, and that is quite limited for me. But I did enjoy learning STM8 and just doing this design, especially with my partner, with coming up with how this was going to work. And it of course is open source, so you can change these to do whatever you want. You can repurpose the KiCad files for your own design, or you can just order one of these. Now, if anyone wants, I've got 10 of these that I can assemble. I might put 5 up as a limited edition sale. So if you want one, message me or leave a comment and I'll put them up. Due to the time and everything put in, they will probably be about $50 each. I know they're not worth that much, or not to everyone, but to me they are, because this was dozens of hours and they'll never be made again. Now, PCBWay are going to have them available as Christmas gifts for certain partners, I believe, and the only limitation is that, of course, they can't ship with a LiPo battery, so I would recommend just grabbing one from eBay. This is a little $3 battery, and you can plug that straight in. So yeah, that was my submission, and I hope you learned something from it. I hope you enjoyed this slightly different format video. I don't do a lot of PCB stuff, but I really, really do enjoy it. And essentially I run this channel to support me doing PCB stuff because I don't make any money from this. It just all goes back into my tinkering, as I say. So thanks again to PCBWay for sponsoring this and for running this competition. Thanks to the creators of STM8 Arduino and to the WS2812 libraries. There'll be links to their work below. Congrats to all the other entrants that won. Thank you to you guys for coming by and supporting this channel, liking, thumbs up, all of that good stuff. And of course, thank you to my patrons. So if you didn't know, I do have a Patreon account and I put stuff up here. You get to see videos ad-free before they go out, like this one's about to. You get to see some behind the scenes stuff, even including, upgrading my computer, building this new room that I'm working in now. And it starts as low as $4 Australian, so about $3 US in freedom dollars, and you get recognition like these lovely folks are. But of course, I'm going to give you a hand if you get stuck with with SBCs, because that is mostly what I do. So thank you to my patrons. I will see you guys in a week or two with some more RISC-V content, it looks like. Take it easy.